Okay, we have looked at several different methods for solving quadratic equations. Chapter 5, we've talked about different ways of factoring. The beginning of this chapter, we talked about having quadratic equations with perfect squares, so that we had the square on one side and we took the square root of each side. The last lesson, we talked about completing the square, which meant we created a perfect square trinomial so that we had a perfect square on one side and then took the square root of both sides. So we're going to continue on with our different methods for solving quadratic equations. And today we're going to talk about the quadratic formula. And the quadratic formula is basically just a formula uh, where it says x equals, and then I just plug in different values and it will give me the factors for that particular equation. So the way I'm going to find the quadratic formula is I'm going to start by completing the square. I'm going to take a standard, this is a quadratic equation in standard form. I'm going to take this and I'm going to complete the square to solve for x, and then I will have the quadratic formula. So let's start. The first thing I need to do is I notice that I have this a in front of my x squared, and in order to complete the square, the coefficient of x squared can only be 1. So I'm going to start by dividing everything by a, okay, everything including the 0, and that's going to give me x squared plus b over ax plus c over a is equal to 0. Okay, now I need to get rid of the c over a because it's not helping me at all. So I'm going to subtract it from both sides. So I will have x squared plus b over ax. I'm going to leave a space equals negative c over a. Okay. I now need to figure out what's going to go in here. So what I'm going to do, and I'm going to do this up here, is I take my coefficient, which is b over a. I would divide it by 2, which, because it's a fraction, I just multiply the denominator by 2. Okay, so the same as multiplying by 1/2. And then I'm going to square both sides. Or actually, I'm just going to square the whole thing. So this becomes b squared over 4a squared. This is what I'm going to plug in then into my equation here. So this becomes plus b squared over 4a squared. And here I have plus b squared over 4a squared. This side then factors x plus, and then whatever I had before I squared it, which was b over 2a. The whole thing squared. So that was the easy side. This side now, I need to add these two together. Okay, what I'm going to do is I'm going to change this. The common denominator is going to be 4a squared. So I have negative c over a, and I'm going to multiply that by 4a over 4a, which is going to give me negative 4ac all over 4a squared. So I have negative 4ac over 4a squared plus b squared over 4a squared. And if I add those two together, I'm just going to rearrange the order. I'm going to have b squared minus 4ac all over 4a squared. Okay, I am now ready to take the square root of both sides. And this is just going to be x plus b over 2a. This is going to be plus or minus. Now I can divide this up. I can do the numerator and denominator separately. There's nothing I can factor out of b squared minus 4ac because it's an expression, so I have to leave it in the radical there. But 4a squared is a perfect square, and I can take the square root of that, which is 2a. Notice that my denominators are both the same, and that's usually what happens when we're completing the square. Okay, so I'm going to move this up here. What I'm going to do is I'm going to subtract b over 2a from both sides. But instead of writing it behind here, I'm just going to put it in the front. So it's minus b over 2a plus or minus b squared minus 4ac, the square root of that, all over 2a. So x is equal to negative b plus or minus b squared minus 4ac all over 2a. That is the quadratic formula. And if you look here, there it is. There's a quadratic formula. Notice that it has a, b, and c in it. And if we have our equation, our quadratic equation in standard form, here's my a, here's my b, here's my c. All we have to do is make sure the equation is in standard form, pull out the values for a, b, and c, plug them into our formula, and we can solve for the roots. So let's look at our first example. Okay, here I have r squared minus r minus 12 equals 0. It's in standard form, so I can pull out my values. A is equal to 1, B is equal to -1, and C is equal to -12. Now, when we completed this square, if A was something other than 1, we had to divide. When we're using the quadratic formula, it doesn't matter if A is something other than 1. We just plug in that value. So I have R is equal to minus B. B is -1, so I want the opposite of that, which is going to be +1. B squared is 1 minus 4 times A times C, all over 2 times A. So 1 plus or minus 4 times 12 is 48. The two negatives make it positive. 48 plus 1 is 49 over 2. This becomes 1 plus or minus 7 over 2. So I'm going to have two solutions because this whole thing was positive. So I have 1 plus 7 over 2, which is equal to 8 over 2, which is 4. And r is equal to 1 minus 7 over 2, which is equal to -6 over 2, which is equal to -3. So my solutions for r then are 4 and -3, okay, which I could have gotten that by just doing regular factoring, but this was good practice. All right, so let's look at our next example. Now, what you might notice about this is that it is not in standard form, so we need to put it in standard form. So I'm going to go ahead and move the -x² over here. I'm just going to write it out this way. So it becomes +x² minus 20x plus 19 equals 0. All I did was put it in the right order. So A is going to be equal to 1, B is equal to -20, and C is equal to +19. And I'm going to write the formula up here again. X is equal to -b plus or minus b squared minus 4ac over 2a. And eventually you'll have it memorized. Okay, so x is equal to the opposite of b. B is -20, so it becomes a +20, plus or minus. B squared is 400 minus 4 times a times c all over 2 times a. Okay, so this becomes 20 plus or minus 400 minus 76 all over 2. 20 plus or minus 400 minus 76 is 324 all over 2. So this is what I've got. Okay, if I take the square root of 324, I get 18. So this should be 20 plus or minus 18 over 2. So I have x is equal to 20 plus 18 over 2, which is 38 over 2, which is 19. Here's one answer. Then I have x is equal to 20 minus 18 over 2, which is 2 over 2, which is 1. So my answer should be x should be equal to 19 and 1. And it's a good idea to go back and plug them in, make sure they work, okay? And they should work because I checked these. All right, let's look then at our proof. Okay, we're going to use the quadratic formula to solve these. First thing is make sure that it's in standard form, which this is. My A is equal to 6, my B is equal to 17, and my C is equal to 12. So if I plug in my values, the opposite of B is -17, plus or minus. B squared, 17 squared is 289, minus 4 times 6 times 12, and I'll write it out, all over 2 times 6. So that's going to give me -17 plus or minus 4 times 6 times 12 is 288. 289 minus 288 is the square root of 1 all over 12. So I have h is equal to -17 plus or minus 1 over 12. So h would equal -17 plus 1 over 12, which is -16 over 12, which is equal to -4/3. And I would have h is equal to negative 17 minus 1 over 12, which is negative 18 over 12, which is equal to, if I divide them both by 6, I get negative 3 over 2. So these are my two solutions, negative 4/3 and negative 3 over 2. Let's look at this one now. I need to put it in standard form first. So it's going to be negative 6r squared plus r. I bring the 1 over, so it becomes plus 1 equals 0. So a is equal to negative 6, b is equal to 1, and c is equal to 1. Okay, plug them in. And r is just interchangeable with x. It's just whatever your variable is. So the opposite of 1 is negative 1, plus or minus. B squared is just going to be 1 minus 4 times a times c all over 2 times a. And that's going to give me negative 1 plus or minus. 4 times 6 is 24. It becomes a positive 24, so this becomes a positive 25 over negative 12, which is negative 1 plus or minus 5 over negative 12. So my two solutions, r is equal to negative 1 plus 5 over negative 12, which is 4 over negative 12, which is negative 1/3, and r is equal to negative 1 minus 5 over negative 12, which is negative 6 over negative 12, which is equal to positive 1/2. So r is equal to negative 1/3 and positive 1/2. Okay, last one. This one I could probably solve a different way, but we're going to go ahead and use the formula. Put it in standard form. Notice that there's no c. All that means is that c is equal to 0. C can be 0 and b can be 0. A cannot be 0 because if it's 0, then it's not a quadratic equation. So b is going to be negative 4 and c is 0. So k is equal to negative b, which becomes positive 4, plus or minus b squared, which is 16, minus 4 times a times c. Remember, c is 0, so this whole thing becomes 0, all over 2 times a. So this is going to give me 4 plus or minus the square root of 16 all over 18, which is 4 plus or minus 4 over 18. Okay, so then I have 4 plus 4 over 18, which is 8 over 18, which is, if I divide them both in half, that's going to be 4 over 9. So there's one solution. And then I have 4 minus 4 over 18, which is equal to 0. So those are my two solutions. Remember, 0 is a perfectly legitimate number. This tells you how many roots. This was positive, so I should have 2 answers. If I look at all my examples, positive, so 2 answers. Where's this one? Yeah, this was positive, so 2 answers. Okay, sometimes you will get 0. If this is 0, you're still going to have 1 answer. It's just whatever this is over this. If this is negative, then you're done. There's no solution. There's no real solution. So that's how we use the quadratic formula to solve quadratic equations.